All right, in that last example, we looked at sketching the graph of the derivative of a function. And we did it by trying to estimate the slopes of the tangent lines to the function at various points. All right, that gets a little tedious because it's kind of hard to draw tangent lines and estimating their slopes. It can be a little tricky, but we really don't have to get that specific. Now, in this example, we've got several graphs, and we're trying to sketch the graph of its derivative. The first one is actually pretty easy to just estimate the slope. And so you can see if we go from, here's one point, we can look at, this function is linear. It's actually an absolute value function, right? So it's linear with a sort of a discontinuity here. But so you can see that we're going down 2 and over 1. So here on this side of the y-axis, the slope is equal to a -2, right? So it's down 2 over 1. On the other side, you can see it's linear, but now the slope we're going up 2 and over 1, right? So the slope is equal to a +2 over here on the right-hand side. So what does the derivative look like? Well, all right, so it's just going to be a constant -2 until we get to 0, right? Now I'm going to put an open circle at x equals 0 because I really don't know what the derivative is at that particular point, right? It looks like if I approach it from this direction, it looks like the slope is 2. If I approach it from that direction, the slope looks like it's -2. So the derivative doesn't actually exist at that particular point. So I'm going to put an open circle here too, for x greater than 0, the slope is a +2. All right. So that's what the graph of the derivative would look like, right? And we have this discontinuity at x equals 0. All right. So now here we have a curve, right? So it's a little tricky to draw tangent lines and actually estimate particular values of the slope. So, but we can see, I always usually start looking where the function is increasing, where it's decreasing, and then where it's changing directions. Where it's changing directions, there's the tangent line is going to be horizontal, so the derivative is 0. All right. Here on the left side of that point, f prime, it's an increasing function, so the derivative is greater than 0. And on the right-hand side, the function is decreasing, so the derivative is less than 0, right? Because decreasing means a negative slope. Increasing means there's a positive slope. So what I can do, I'm trying to sketch the graph of the derivative down here. And so I know where it's 0. It's 0 when x is equal to 1. So I can actually plot that point. And then it's positive, right? The slope is positive, right? It's an increase. The function itself is increasing when x is less than 1. So it's going to be I've got positive values. Now I don't really know, I haven't actually estimated points, but I'm just going to make it's positive, right? It's positive to the left of 1, and to the right of 1 it's negative. So this would be a possible graph. It could be a linear function. So that's a sketch for a possible graph of the derivative of that function. Okay. All right. So again, it's just a matter of looking at where the function is increasing and where it's decreasing. And if it's changing directions at some point, like up here, you can plot the point where it's equal to 0. Now in this case, it looks like this is decreasing, right? the slope is downward. If I drew a tangent line at any point along this curve, it's decreasing, right? It looks like it's close, it gets closer to 0, so f prime, I can say it's approaching 0 if we go this direction, but f prime is decreasing, so the function is decreasing, so that means that the slope is negative, which means the derivative is less than 0. All right. Same way on this side, right? We have this discontinuity at 0, but if I draw tangent lines at any point on this side of the graph, f prime is also less than 0, so it's decreasing everywhere. And as x gets larger and larger, it looks like it's approaching 0 over here. Now here it's just f prime is approaching, it's getting more and more negative, right? It's steeper and steeper, but it's in the negative direction, so I could say it approaches negative infinity, right? Same way down here, f prime approaches a negative infinity, right? It's getting steeper and steeper in the negative direction. So what does that look like? It looks like that. It looks like this. Scroll down just a hair. It looks like the derivative is always negative, and in the extremes, at the end behavior of the derivative, it looks like it's going to 0. So I have something that's going to look like that, something that's going to look like that, and then as x approaches 0, it looks like there's an asymptote at x equals 0, right? Because it's always negative, but it's getting larger and larger in a negative direction as x approaches 0 on either side. So it looks like we have something that looks like that. All right. So so that would be a possible, that would be a sketch of the graph of the derivative of that function. This is actually 1 over x. This is the graph of 1 over x. Turns out that this is a negative 1 over x squared. So we'll get into that more later on. All right, so that's all I have for you, and I will see you in class.